Hi students, good evening. So welcome to the seventh session on work energy and power topic. In Canada, we look at the applications of the work energy theorem. So this is the main crux of the chapter. And maximum the questions will be coming from the applications of the work energy theorem. Okay, va? So there are different categories. So I mean, it's not like applications of the work energy theorem. All the problems will not be in the same domain. So what we'll do is we'll try to divide the problems. So we'll try to divide the problem into different types so that when you are looking at a particular problem, right, we'll have a better recall ability. So when we look at any problem, right, if you are able to understand what is the kind of a model that is, you can easily approach it. So you will be able to save the time. So we'll try to divide the applications of this work energy theorem into different models. First, we'll start with the applications of the work energy theorem with regard to the kinematics related problems. Okay, so first type we are looking at the applications of this work energy theorem related to what the problems in terms of this kinematics, means what? Motion. Okay, va? So we'll start. Paranga, a body is thrown upwards. Remember in kinematics, right? If you are throwing an object from the surface of the earth, throw panna with a velocity u. Now we have derived this H max formula. H max evla. What is the H max value? What is it? U square by two g, right? What is the maximum height up to which the particle will go? U square by 2g. Okay. So if we'll try to derive this. This is the H max formula. So if you are throwing an object with a velocity u from the surface of the earth, it will go to how much maximum height? U square by 2g. Okay. So we'll try to derive this H max formula by using what? By using the work energy theorem concept. So the derivation this will also be useful in solving problems. Past year NEET I think we got, one question has come based on this particular model. So what is it? The vertical motion of the object. Adilla using the work energy theorem concept. Paranga, what we'll do? So we will consider the initial point where on the surface of the earth when you are throwing it. Okay. So the particle is going upwards it is going and reaching the maximum height. See, maximum height and so now what is the significance of that point? And the object of velocity becomes 0. Maximum height of significance and the velocity of the object becomes 0. So this is the final location. So neglecting is very important. Neglecting air resistance. Air resistance considered. We are neglecting the air resistance. So neglecting the air resistance, paranga, when that object is going up, force gravitational force. Air resistance neglect panna. What is the only other force? Gravitational force. Gravitational force or impact is already coming in the potential energy term. So other than the gravitational force, there is no other force acting on that object. Okay, so because we are neglecting air resistance, since there is no other force, work done by the non-conservative forces and other external forces. Other value since there are no forces itself, other value 0 since there are no non-conservative forces and external forces, work done by them will be what? 0. So this is what? This is the condition for what? Conservation of mechanical energy. These are a condition. What is the condition going to be called as? Conservation of mechanical energy. Means what? When the work done by the non-conservative forces and other external forces is zero, it means what? Delta Ke plus delta Pe or value will become zero, which means what? Ke final minus Ke initial plus Pe final minus P initial is equal to 0. இப்போ நம்ம இனிஷியல் டேர்ம்ஸ் மட்டும் அந்த பக்கம் எடுத்துட்டு போலாம். வாட் வில் ஹேவ்? லெஃப்ட் சைடில் Ke final plus P final இருக்கும். ரைட் சைடில் this Ke initial and P initial will become positive. So what is the relation we'll have? That is what we call as what? Conservation of mechanical energy. பாருங்க, what is it? The kinetic energy plus potential energy ஓட value that is going to remain constant throughout the motion. So what is it? Ke final plus P final order value, right, will be equal to what? Ke initial plus P initial. So this is the conservation of mechanical energy and so okay va? So since in this particular motion we are neglecting the air resistance, other than gravity there is no other force, so work done by the non-conservative forces and other external forces are zero. So what is the result of that? Mechanical energy value will remain constant. பாருங்க, initial state kinetic energy எவ்வளோ? Let us consider the object is having a mass m ன்னு வச்சுக்கோங்க. அது final answerல வராது. Okay, kinetic energy எவ்வளோ? half m u square. Initially எங்க இருக்கா? Where is this object? Surface of the earth க்கு மேல தானா? So potential energy எவ்வளோ? 0, because that is our reference. Final kinetic energy எவ்வளோ? 0. Why? Because at the maximum height அதோட velocity becomes 0. So kinetic energy எவ்வளோ? 0 தானா? Potential energy எவ்வளோ final stateல? It is at a height h above the surface of the earth. So potential energy எவ்வளோ வரும்? mgh. Apply that conservation of mechanical energy principle. What is it? K initial plus P initial means half m u square plus 0 is equal to Ke final plus Pe final, 0 plus mgh. அங்கே என்ன வரும்? half m u square is equal to mgh. m cancel ஆயிடும். So பாருங்க, u square by 2g is equal to h. இதுதான் maximum height. இதனது maximum height. ஓகேவா? So இப்படி we can calculate what is the maximum height that a particle can attain by using the work energy theorem. இங்க என்ன தெரியுமா? Why we are doing this derivation? ஏன்னா நம்ம அப்படியே ரிசல்ட் சொல்லி நம்ம we could have gone to the next point. பட் எதுக்கு தெரியுமா? This idea will be used in solving problems. எப்படின்னு சொல்லிட்டு நான் காமிக்கிறேன். So next we'll see some example. பட் இங்க ஐடியா என்ன தெரியுமா? The kinetic energy plus potential energy will be conserved, which means what? இங்க பாருங்க, we are looking at only initial point and final point. பட் இங்க மட்டும் கிடையாது, நடுவில் you take some other points. இங்க point 1 எடுங்க, அந்த மாதிரி point 2 எடுங்க, அந்த மாதிரி point 3. K initial plus P initial ஓட value, right, will be equal to kinetic energy at the point 1 plus potential energy at point 1. ஏன்னா அங்க இருக்கிற what is the total mechanical energy means kinetic energy plus potential energy தானா, which will be equal to what? The kinetic energy at point 2 plus potential energy at point 2, which will be equal to kinetic energy at point 3 plus potential energy at point 3. That will be equal to what? The final state, which is the maximum height point. அங்க இருக்கிற kinetic energy plus potential energy. So இதுல இருந்து வர மெசேஜ் என்ன? That conservation of total mechanical energy, right, இது வெறும் அந்த initial point final point மட்டும் கிடையாது. This mechanical energy conserved means what? At each and every point in the path. நீங்க எங்க வேணாலும் இருக்கலாம். At each and every point on the path, the total mechanical energy ஓட value will be what? Constant. ஓகேவா? So that is what we call as the conservation of mechanical energy principle. எப்போ அது applicable ஆகும்? When work done by the non-conservative forces like friction and the மாதிரி, or any external forces, if that value is 0, then we will have what? Delta Ke plus delta Pe will be 0. அதிலிருந்து we will get what? Ke plus P, and the term will be what? Constant throughout the journey. That is what we call as conservation of mechanical energy principle. இப்போ பாருங்க, based on this we will look at a question. an object is thrown upwards with a velocity of 20 meter per second. What is the initial velocity? 20 meter per second. Find its velocity at half the maximum height. So paranga, so this is the highest point vechukonga. This is the highest point. avanga enna kekranga at half the maximum height. At h by 2, what is the velocity? At h by 2, what is the velocity? Okay. In the question enna theriyuma, we can solve it by using the kinematics principles also. Every, like, we can first find what is the maximum height. Adu namakku theriyum already, standard formula da. Adukaprom half the maximum height inga paranga. Half the maximum height, first enna theriyuma, we'll find what is the maximum height. Maximum height evla? U square by 2g dana. So u square means what? 20 square by 2 into g evla 10. Paranga 20 square by 20 means what? That is 20 meters varum. This is the maximum height value. Half the maximum height is what is it? H by 2, that is 10 meters. So ipo nama enna calculate pananum? When it is going up by 10 meters, anga irukra velocity, we have to find what is the velocity at half the maximum height. Okay. So eppadi theriyuma, we can solve this problem by using two methods. Kinematics and the equations of motion approach panni solve panala. Ingona we can solve it by using the work energy theorem principle. Ingana theriyuma, because we are doing work energy, let us use the work energy principle. So paranga, initial point, surface point, right, we will call it as 0.1. Half the maximum height, we are calling it as 0.2. So here air resistance, generally when they are not talking about the air resistance, adu patta avangal pesalana, we will have to consider that it is neglected. So air resistance is what? Neglected. Ipo paranga, air resistance neglected means work done by the non-conservative forces and external forces evla 0. So we will have that conservation of total mechanical energy principle. So Ke at 0.1 evla? Half into m into 20 square. Okay, half mv square. Pe at 0.1 evla? 0, because that is surface. Ke at 0.2, half into m into v square. In the v da namakku venum. P at 0.2 evla? It is at a half the maximum height is what? 10 meter. Maximum height is 20 meter. Half the maximum height means 10 meter. So at this location, what will be the potential energy? Mg into 10. Half the maximum height is what? 10 meter, right? Paranga. So conservation of mechanical energy means what? Ke at 0.1 plus Pe, which is what? Half into m into verum 20 square plus 0 is equal to what? Half into m into v square plus mg into 10. Okay va? Inga paranga, m cancel aadum. 20 square evla? 400 divided by 2, which means what? 400 divided by 2 is what? 200. LHS la enna 200 is equal to, inga enna varudhu paranga, half v square irukum. G into 10 means what? G is 10. So 10 into 10 is what? 100. Okay va? So அப்படியே நம்ம அந்த ரைட் சைடுல இருக்கிற 100, ரைட், லெஃப்ட் சைடு எடுத்துட்டு வாங்க. லெஃப்ட் சைடு எடுத்துட்டு வந்தா it will become what? Negative தானா? So இந்த இப்படியே நம்ம லெஃப்ட் சைடு எடுத்துட்டு வந்தா it will become what? Negative. So LHS ல என்ன இருக்கும்? 200 minus 100 is equal to half v square. 200 minus 100 means what? Is another 100. 100 is equal to half v square, which is what? 2 numerator la poidum. So 200 is equal to v square. Idhula irundhu root 200 is equal to v. Root 200 means what? 10 root 2. So at half the maximum height, right, what is the speed? It will be 10 root 2 meter per second. Check panunga. What is the answer we should get? 10 root 2 meter per second. So guys, you have to confirm whether you are getting the answer or not. You have to confirm it, guys, whether you are able to get it or not. What is the velocity at half the maximum height? It will be what? 10 root 2 meter per second. Means root 2 badalana we can take it as 1.414. Editha we'll get it as what? Approximately in terms of decimal value 14.14 varum. Okay va? So ingana theriyuma. So this is a very specific example. This is a very specific example. Ingalanda we will try to derive some standard results. In a maximum neat we will have to look at all these standard results. Maximum angalanda questions varum. Okay. So idu eppadi nama generalize pandrathu? Paranga, if you are starting with a velocity u, h max value namakku theriyum. What is the h max value? U square by 2g, right? Half the maximum height and sonna adula half value, which means what? U square by 4g. This is half the maximum height. Okay va? So we are going to do the general result. Paranga. So half the maximum height means what? U square by 4g. So initial point, kinetic energy half mu square, potential energy 0. Initial point 0.1. Point 1 that is half the maximum height point. Anga kinetic energy half mv square. In the v then namakku venum. Half mv square plus potential energy m into g into that half the maximum height. What is the half the maximum height? Means u square by 4g. Paranga. First m cancel adum. Okay, adukaprom we can cancel g also here. G nama cancel pannala. Enna varum paranga? Half u square is equal to what? Half v square plus idanadi u square by 4. If we'll just multiply both sides by 2. 2 which nama multiply pannala. Multiply panna enna varum? U square is equal to idanadi v square plus u square by 2. Appadi and the u square by 2 nama left side eduthu varala. It will become what? Minus u square by 2. So u square minus u square by 2 is equal to v square. What is u square minus u square by 2 means? This is like what? X minus x by 2. What is it? So paranga, what is the v value? Nama root edutha, what is it? U divided by root 2 is the. So at half the maximum height, formula na. What is the velocity of that object? U divided by root 2. Now what is the formula? U divided by root 2. Check panla. So what is the u value? 20, right? So at half the maximum height, right? Already we have answer at half the maximum height. At half the maximum height, what is the velocity? U by root 2. This is a standard formula. If you substitute paranga, u have 20 meter per second divided by root 2. We can write it like what? 10 into root 2 into root 2. What is it? Root 2 cancel it. Same answer dana. So nama standard in the general formula and sonna that should give us at least minimum whatever is the previous answer we got, right? So this is the standard result. So they are giving us some other question. Initial velocity 40 and so on. Then what we will do? Velocity at half the maximum height will be what? 40 by root 2. If they are saying initial velocity with which you are throwing up is 70, then velocity at half the maximum height will be what? 70 by root 2. Okay, so this is the general formula to find the velocity at half the maximum height. Like for majority of these standard kind of model questions, right? We will have to get these general results. Okay, so in the general results, then we will be able to save a lot of time while solving problems. This is the trick. The trick is what? When you have all the general formulae or the general results, then you will take less time to approach a question. What you have to do? Beginning solve. See, same in the question final exam. The person who is able to remember the formula, Tucker and the U value put, you will just get the answer in less than even 30 seconds. Answer. But who would not know this formula, right? What he will end up doing? Beginning he has to apply that conservation of and the மெக்கானிக்கல் எனர்ஜி அப்ளை பண்ணி அதுலேருந்து ஆன்சர் வரும். You will get it, but you can save some time and use the time for some other difficult questions. ஓகேவா? ஸோ இதில் நம்ம இங்கே கொஞ்சம் காம்ப்ளெக்சிட்டி போகலாம், பட் ஸோ இங்கே என்னென்னா we'll try to hold it. So maybe later we can also derive a general result for the velocity at என்ன தெரியுமா, இங்கே என்ன சொல்லியிருக்கோம், half the maximum height. They can also say 1/3 of the maximum height, 1/4 of the maximum height, 1/5 of the maximum height. அப்படி சொல்லலாம். அதுக்கு ஜெனரல் என்ன தெரியுமா, they can say what is the velocity, maybe நீங்க ட்ரை பண்ணலாம் இந்த ரிசல்ட், what is the velocity at 1/nth of the maximum height. so இங்க n என்ன தெரியுமா, அது ஜெனரல் வேல்யூ. so n is 2 means half of the maximum height, n is 3 means 1/3 of the maximum height, n is 4 means 1/4. அப்படி n is 5 means what, 1/5 அந்த மாதிரி போயிடும். ஓகேவா? so this also you can try and do the general result. நீங்க ட்ரை பண்ணி பார்க்கலாம். so what is the velocity of that object which is projected up at 1/nth of the maximum height. ஓகேவா? look at this oblique projectile. oblique projectile என்னது, we are projecting an object and making an angle theta with the horizontal. இதுதானா? so the entire journey will be like what, it will be like a parabolic curve. adula we have two important points, h max and then range. இது an oblique projectile. so இங்க பாருங்க, initially we are having a velocity u making an angle theta with the horizontal. so இப்ப பாருங்க, what is the initial kinetic energy, எவ்வளவு, half m into u square. if you neglect air resistance வச்சுக்கோங்க, if you neglect air resistance, then what we should have, we should have the total mechanical energy. ஏன்னா gravitational force தவிர there is no other force, which means work done by the non-conservative forces and other external forces எவ்வளவு, 0 தானா? இந்த gravity தவிர there is no other force, neglecting air resistance. ஆமா, fire பண்ணதுக்கு அப்புறம் that is it, right? it is moving under the gravity only. so if the work done by the non-conservative forces and other external force is 0, which means what, that is giving us what, the conservation of mechanical energy. அதுல இருந்து நமக்கு என்ன வரும் ரிசல்ட், mechanical energy conservation. அதுதானா? which means what, kinetic energy ஓட value plus potential energy value will remain the same. so இங்க பாருங்க, initially kinetic energy எவ்வளவு, half m u square, potential energy 0, ஏன்னா நம்ம surface of the earthல இருந்து நம்ம ஃபயர் பண்ணிருக்கோம். ஓகே, திருப்பி இங்க பாருங்க, when it comes to the ground again, அந்த பக்கம் when it comes to the ground again, let us call it as what, இது நம்ம 0.1 ன்னு வெச்சுக்கோங்க, இது 0.2. here we don't know the velocity, imagine இங்க நமக்கு velocity value தெரியாது, let us call it as v. so kinetic energy எவ்வளவு, half m v square. potential energy என்ன, திருப்பி it is coming back to the same surface level தானா, which means what, potential energy 0. so apply பண்ணி பாருங்க, the conservation of mechanical energy, இங்க இருக்கிற ke value plus pe, which is half m u square is equal to அந்த final stateல இருக்கிற kinetic energy plus potential energy half m v square. half m v cancel ஆயிடும். so u square will be equal to v square. இதுல இருந்து என்ன வரும் தெரியுமா, the modulus or the magnitude will be same. direction wise they will be, orientation will be different. இங்க பாருங்க, when it is coming to the surface on the other side, the direction of the velocity will be different, but magnitude will be same. Why means because the conservation of mechanical energy. so the magnitude of the final velocity when it is reaching the surface again, what is it, it will be same as the magnitude of the initial velocity. it will be same as the magnitude of the initial velocity. okay va? okay, அடுத்த பாயிண்ட் என்ன பாருங்க, if you look at this maximum height point, இங்க என்ன தெரியுமா, the total velocity will be only the horizontal component. what is the value, u cos theta. the object of the total velocity will be what, only the horizontal component தானா, that is what u cos theta. so இங்க kinetic energy value என்ன பாருங்க, what is the kinetic energy here, half m into u cos theta the square. What is the kinetic energy value? Half m into u cos theta the square. So generally என்ன தெரியுமா, we can have questions like this. What is the ratio of, இப்படி கேட்கலாம், what is the ratio of kinetic energy at h max to the initial? The ratio of velocity, the ratio of kinetic energy. பாருங்க, what is the ratio of kinetic energy? Half m u square cos square theta divided by, what is the initial kinetic energy? Half m u square. Cancel பண்ண, what is it? Cos square theta. Means at the maximum height, let us say k dash வச்சுக்கோங்க, kinetic energy. Original kinetic energy is k, initial kinetic energy. So k dash by k எவ்வளவு? Cos square theta. So இது நம்ம இப்படி எழுதலாம். What is it? K dash is equal to what? K into cos square theta. K dash is what? Kinetic energy at the maximum height. K is what? The kinetic energy at the point of projection. Okay, wow? So this is the relation in terms of the kinetic energies. There is a relation in terms of the kinetic energy. In another, we can try to look at how the conservation of this mechanical energy will be satisfied. It will be satisfied at each and every point. ஒரு பாயிண்ட்லயும் இந்த principle will be satisfied. நீங்க செக் பண்ணி பார்க்கலாம். Like, you know, at the maximum height point, right? At the maximum height point, பாருங்க, what is the kinetic energy? Half m into u square cos square theta. What is the potential energy? பாருங்க, what is the potential energy? M into g into h max. H max means what? U square sin square theta by 2g. அதுதானா? What is the h max formula for the oblique projectile? U square sin square theta by 2g. இந்த பாருங்க, g cancel பண்ணலாம். Half m u square cos square theta எங்க இருக்கா? Half m u square sin square theta. இதுல நம்ம அப்படியே அந்த half m u square காமன் எடுக்கலாம். ரிமைனிங் என்ன இருக்கும்? இங்க cos square theta, அங்க sin square theta. What is cos square theta plus sin square theta ஓட வேல்யூ? 1 தானா? So பாருங்க, the total இது என்னது? Total mechanical energy. Total mechanical energy என்ன பாருங்க? Initial state ல what is the total mechanical energy? Half mu square plus 0. Same தானா? So the initial state, whatever the total mechanical energy, will be remaining same throughout the journey. Okay. So any point, இப்போ நடுவுல you take some other point, இங்க ஒரு point நம்ம எடுத்து வச்சுக்கோங்க. There also what is the principle? The total mechanical energy means kinetic energy plus potential energy will be remaining same as the initial value. Okay, wow? So this conservation of mechanical energy will be satisfied for the oblique projectile motion also. Oblique projectile மட்டும் கிடையாது, it will be satisfied for the horizontal projectile also. We can say it will be satisfied for any projectile motion, provided நம்ம என்ன பண்ணணும்? We should neglect the air resistance. Okay, neglect பண்ணலன்னா then what is it? We are going to have the non-conservative force, which is the air friction or air resistance. Then this conservation of mechanical energy principle, right, அது அங்க applicable ஆகாது. Okay, so we are assuming that the air resistance is not there and solid. Okay, அதனால we are getting what? The conservation of the mechanical energy principle applicable. So it is applicable for what? The vertical motion of the object, like நம்ம இதுக்கு முன்னாடி பார்த்த மாதிரி, and it will be applicable for the oblique projectile motion, horizontal projectile motion, everything. Okay வா? பாருங்க, this kind of questions can be asked. An oblique projectile has an angle of projection எவ்வளவு? 30. Means this is the angle, whatever is the initial angle that we take, right, and then that is what we call as the angle of projection. What is the ratio of kinetic energy at the maximum height to the initial kinetic energy? இது ஒரு standard question நான் சொன்ன மாதிரி. What is it? They are asking what? K dash by k. What is the value? Cos square theta தானா? What is the K dash by k ஓட value? Cos square theta. பாருங்க, good Maithili. What about others? You are not giving any responses. Okay va? So what is the answer guys for this? K dash by K evala cos square theta, which means what? Cos square 30 avladana. So what is cos 30 evala? Root 3 by 2. Root 3 by 2 dana. So cos square 30 means what? Root 3 by 2 the whole square. Adana 3 by 4. Okay, good guys. So I need to see some more responses so that I will know you guys are able to follow the session. Okay. So அடுத்தது என்ன தெரியுமா, we will go to the next some general cases based on the applications of the work energy theorem with regard to this kinematics kind of problems. இங்க பாருங்க, find the horizontal velocity of the particle when it reaches point Q. Assume the block to be frictionless and the particle is starting from rest at point P. எங்கிருந்து it is starting from rest at the point P. So அங்கிருந்து start ஆயிட்டு it is coming along the inclined plane. So inclined plane கிடையாது, it's a surface. Okay. So it is coming along the surface. Remember we talked about it. When any object is moving along the contact plane, work done by the normal reaction equal to 0. When any object is moving along the contact plane, work done by normal reaction equal to 0, which means there will be no work done by the normal reaction. In this journey, there will be no work done by the normal reaction. Okay va? Adukapram what they are saying, frictionless. Frictionless means what? Friction கிடையாது. Okay. So other than normal reaction, வேற என்ன இருக்கும்? Gravity தானா? The only other force is gravity, which means what? When the 2 kg mass is moving from point to length, it is moving and coming all the way up to what? Point Q. The point P length start பண்ணிட்டு it is coming all the way up to point Q. When it is coming in this journey, right, work done by the non-conservative forces and other external forces is what? 0. When it is moving, because other than gravity there is no other force which will be doing work, because ஒரே ஒரு force இருக்கா, what is it? Normal reaction. That also, since the object is moving along the contact plane, right, work done by the normal reaction equal to 0, which means we can apply, since work done by the non-conservative forces and other forces is equal to 0 dana, which means what? Change in kinetic energy plus change in potential energy equal to 0. That is what is our conservation of mechanical energy principle. Same concept. இங்க பாருங்க, இப்போ இது நம்ம ரெஃபரன்ஸ் எடுக்கலாம். This is what our reference. இது நம்ம ரெஃபரன்ஸ் எடுத்தா, what is the height of the point P above the reference? 1 meter. So initial potential energy எவ்வளவு? Mass of the object is 2. G is 9.8. So 2 into initial potential energy, 2 into m into g into h தானா? 1. So இங்கிருந்து நம்ம எடுத்திருக்கோம். Reference is the point, the flat surface. Okay வா? K initial equal to 0. ஏன்னா they are saying what? The particle is starting from rest from P. Okay வா? அப்புறம் we have to look at what is the final. Final means at point Q. Final means we have to look at point Q. Okay வா? So what about the point Q or the height from the reference? Height of the point Q from reference எவ்வளவு? 0.5 meters. So P final எவ்வளவு தெரியுமா? It will be what? 2 into 9.8 into 0.5. Okay. So idanna what is this? This is 19.6. Idanna the 2 into 0.5 is 1. So the 9.8. Ke final adu eppadi half into mass of the object into velocity square. inga parunga, when it is coming to point q, inga surface eppadi iruka, flat dana, which means the velocity will be horizontal. பாருங்க அவங்க என்ன கேக்குறாங்க, find the horizontal velocity of the particle when it reaches point q. When it is reaching point q, right? When it is reaching point q, எப்படி இருக்கும் அதோட velocity will be horizontal. Why? Because the object is always moving along the contact plane dana. If the contact plane is horizontal means the velocity will be horizontal. If the contact plane is having a curvature means the velocity will be along that curvature. So since the point q kitta, it is what, the surface is horizontal, so adanal the velocity at the point q also will be what, horizontal. Okay va? So this v eppadi irukum, it will be horizontal. adha ungalku kekranga. Okay, so look at this, 2 cancel aidum. So what do you have? Conservation of mechanical energy principle means p initial plus key initial evladhu 19.6 plus 0 means 19.6 da is equal to p final plus k final. Then 9.8 plus v square. 9.8 நம்ம left side எடுத்துட்டு போலாம், which means what, it will become minus 9.8. So 19.6 minus 9.8 means வெறும் 9.8. That is equal to v square. So v எவ்வளவு, root 9.8. What is the velocity of that particle at point q? Root 9.8. எவ்வளவு சொல்லுங்க, what is the approximate answer for this? 3.13 dana. What is the approximate answer for this? It will be what, 3.13. check பண்ணுங்க, what is 3.13 into 3.13, right? நீங்க check பண்ணா it will be coming close to what, 9.7 something வரும். Okay, so it will be almost 9.8. ஏன்னா ரூட் 9.8 சொன்னா கண்டிப்பா அது 4 கிடையாது, 5 கிடையாது, 3.6 also will not be. Okay, so we will be able to straight away அப்படியே பார்த்துட்டு we can even generally come to the approximate conclusion that it will be what, 3.13. check பண்ணுங்க. So these square root approximations, right, that we have to be a little bit more comfortable, at least for some of the common things like in the madri root 9.8 வரதுக்கு chances இருக்கும். ஏன்னா when you are solving problems in laws of motion or kinematics or work energy theorem or even next chapter also, in the root 9.8, ஏன்னா g oda value is 9.8, right? So root 9.8 வரதுக்கு there will be lot of chances. So maybe you can remember this, என்னது root 9.8 will be what, 3.13. root 9.8 value na 3.13. okay va? So if you are remembering this means future la edavadhu question vanda you will be able to solve it. Okay, so guys, you have to confirm whether you are able to get it or not. So eppadi nama approach பண்ணிருக்கோம் இந்த problem, same concept. Normal reaction oda work is what, 0, which means நம்ம மத்த friction adalla, friction they are saying is not there, so work done by the non conservative forces and other external forces is what, 0. That is giving us the conservation of mechanical energy condition. அப்படியே நம்ம அதை அப்ளை பண்ணோம், அவ்வளவுதான். So initial kinetic energy plus potential energy. See, potential energy கேஸ்ல என்ன தெரியுமா, we always will measure the potential energy from the reference. இப்போ இங்க நம்ம நம்ம எடுத்தது reference, we are taking this bottom, அங்க கீழ இருக்க தெரியுமா, அந்த surface நம்ம reference எடுத்திருக்கோம். So this is what we have taken as the reference. So initial point P, அதோட height எவ்வளவு, from the reference line 1 meter, final point height 0.5 meter. okay va? So potential energy will always depend upon what is our reference. okay, check பண்ணுங்க. So what is the answer for this? 3.13 தானா? அடுத்த question பாருங்க. This is the case of the inclined plane. An object is allowed to slide down inclined plane of length 20 meter. Angle of inclination எவ்வளவு, 30. இங்க பாருங்க. So this is the inclined plane. இது ஒரு inclined plane வெச்சுக்கோங்க. Is allowed to slide down. Slide down சொன்னா it is sliding down from the top. So மேல இருந்து கீழ வர மாதிரி. Okay. Length எவ்வளவு? So length of this inclined plane எவ்வளவு? 20 meters. It is sliding down along the inclined plane. Angle of inclination எவ்வளவு? 30. Find the velocity of the object when it reaches the bottom of the surface. So இப்படியே இது ஸ்லைட் ஆயிட்டு கீழ வரும். When it is reaching the bottom of the surface, என்ன கேக்குறாங்க? They are asking what is the object velocity. எங்கன்னு தெரியுமா? Here when they don't mention about friction, ஏன்னா whenever they have to talk about friction, right, கண்டிப்பா they have to give us what is the coefficient of friction. அது கொடுக்கலன்னா what is the meaning of that? It is not there. So here what is it? It is a case of neglecting friction. இதென்ன தெரியுமா? We have to neglect the friction. We have to assume it is smooth. அப்படி இல்லைன்னா they would have given us coefficient of friction. அது நம்ம கொடுக்கல. Which means what? We can assume this is a frictionless or smooth case. இங்க பாருங்க. So இங்க என்ன இருக்கும்? Normal reaction will be there. Friction கிடையாது. Then of course there will be gravity. When the object is moving along the contact plane, work done by the normal reaction எவ்வளவு? 0 தானா? When any object is moving along the contact plane, work done by the normal reaction எவ்வளவு? 0. ஏன் why it becomes 0 பாருங்க. Normal reaction எப்படி இருக்கும்? Normal to the contact plane. Displacement எப்படி? Along the contact plane. So அந்த ரெண்டுத்துக்கு நடுவுல what is the angle? 90. If the force and displacement angle between them is 90, right, what will be the work done by the force? 0 தானா? What is the work done? Normal reaction into displacement ds into cos 90 வரும். அதனால it will become what? 0. So whenever any object, ஞாபகம் வெச்சுக்கோங்க, whenever any object is moving along the contact plane, work done by the normal reaction எவ்வளவு? 0. Normal reaction will not do any work. ஓகேவா? So இப்ப பாருங்க, here we can again use conservation of mechanical energy principle. யூஸ் பண்ண முடியுமா? ஏன்னா because normal reaction work is 0. இங்க friction கிடையாது. Which means work done by the non-conservative and other external forces எவ்வளவு? 0. So அதுல இருந்து நம்ம கிட்ட வர ரிசல்ட் என்ன? conservation of mechanical energy means என்ன பாருங்க, we will take this point 1 as the starting point, இங்க the point 2 as the final point when it is touching the bottom surface. Okay, so bottom surface இது நம்ம ரெஃபரன்ஸ் எடுக்கலாம் for the potential energy. இப்போ பாருங்க, initial height எவ்வளவு? vertical height தான் நமக்கு வேணும். So in the triangle, right angle triangle, what is the hypotenuse value? 20 meter. In the angle என்ன? 30 theta. So பாருங்க, what is sin theta oda value? h by l தானா? sin 30 எவ்வளவு? h by l means sin 30 oda value என்ன? half. So h is equal to l by 2. L is 20 meter, right? 20 meter by 2 means 10 meter. இதுதான் h oda value. So using that the properties of triangles, right, அதை யூஸ் பண்ணி we are able to get what is the height of that object at the starting point from the reference. ஏன்னா நமக்கு என்ன வேணும்? we will be requiring what is the vertical height. Gravitation potential energy calculation நமக்கு என்ன வேணும்? we will be requiring the vertical height. Okay, இங்க பாருங்க, what is the k initial? 0. எதனால? they are saying the object is allowed to slide down. Okay, so when it is starting from there, what is the initial kinetic energy? 0. Initial potential energy எவ்வளவு தெரியுமா? what is it? அந்த ஆப்ஜெக்ட் மாஸே கொடுக்கல. so let us consider m into g into 10. why? because it is at a height of 10 meters above the reference. Final kinetic energy, let us say half m into v square. இந்த v தான் நமக்கு வேணும். Final potential energy எவ்வளவு? 0. ஏன்னா it is coming to the reference. கீழ bottom கிட்ட தான வருது. it is coming to the reference means what? Final potential energy 0. so conservation of mechanical energy யூஸ் பண்ண என்ன வரும்? k initial plus p initial means வெறும் அந்த mg into 10 மட்டும் இருக்கும். is equal to what? k final plus p final half mv square. பாருங்க, mm cancel ஆயிடும். g எவ்வளவு? 10. 10 into 10 100. 100 is equal to half v square. 2 numeratorல போய்டும். 200 is equal to v square. so அதுல இருந்து v ஓட வேல்யூ என்ன? root of 200 which is equal to what? 10 root 2. check பண்ணுங்க guys, what is the final velocity when it is coming down? அந்த ஆப்ஜெக்ட்டோட final velocity எவ்வளவு? 10√2 meter per second. இதுல என்னன்னா we are assuming that the surface is what? Smooth. Okay, good Maithili. So we are assuming that the surface is what? Smooth. அதனால we are not talking about the work done by the friction. Okay va? So check it guys, what is the final velocity? The object when it is coming to the bottom, when it is coming to the bottom, what is the final velocity? And the object final velocity எவ்வளவு? 10√2 meter per second. Root 200 means what? 10√2 தானா? Okay, அடுத்த question போலாமா? So this is the question again, inclined plane base பண்ணிதா, but here we are going to talk about the friction included. இதுல என்னன்னா we are going to look at the friction coming into picture. இதுக்கு முன்னாடி நம்ம பார்த்த ப்ராப்ளம் என்ன? friction கிடையாது. So இங்க என்ன வரும் பாருங்க, an object is given an initial velocity of 60 meter per second along an inclined plane, angle 30 upwards. இது எப்படி இருக்கா? So we have an inclined plane, கீழ இருந்து நம்ம ஒரு velocity கொடுத்திருக்கோம். What is the velocity? 60 meter per second along the plane. Okay va? What is the angle of the plane? 30. How much distance along the plane will this object travel before stopping? என்ன கேக்குறாங்க? before stopping, how much distance along the plane it will travel? இப்ப பாருங்க, it is traveling a distance d ன்னு வெச்சுக்கோங்க. என்னது? d is the distance traveled along the plane when it is finally coming to rest or stopping. So inga stop ஆக போறது. Okay வா? We need to find the d ஓட value. அவ்வளவுதான். We need to find what is the d value. இங்க என்ன தெரியுமா? We will just try to find out what is the vertical height. So இப்போ இதுக்கு முன்னாடி நம்ம பண்ண மாதிரி, what is it? இப்போ இது என்னது? d தானா? This is d means நம்ம h ன்னு சொல்லலாம், height. பாருங்க, sin 30 is equal to what? h by d. Sin 30 means half தானா? So h is equal to what? d by 2. So இங்க stopping point எங்க இருக்கோ? So we'll say initial point நம்ம 1 ன்னு சொல்லலாம். Final point is what? 2. And the point 2 ஓட vertical height எவ்வளவு? From the reference d by 2. d is what we are interested. ஏன்னா that is what they are asking, right? அவங்க என்ன கேக்குறாங்க? they are asking what is the distance moved. பாருங்க, what they are asking, how much distance along the plane the object will travel before stopping. So along the plane, the plane ஓட இதுல what is the distance traveled before it is stopping. இங்க என்ன தெரியுமா? look at this. Initially what is the kinetic energy ஓட value? What is the kinetic energy? இங்கேயும் அப்படிதான், அந்த ஆப்ஜெக்டோட மாஸ் கொடுக்கல. they are not giving us the mass of the object. Initial kinetic energy எவ்வளவு? half into m into 60 square. ஏன்னா initial velocity 60. Final kinetic energy எவ்வளவு? 0. எதனால? because it is stopping at point 2, it is stopping, right? So final kinetic energy எவ்வளவு? 0. Initial potential energy எவ்வளவு தெரியுமா? it is starting from இதுதான reference. Initial potential energy 0. Final potential energy எவ்வளவு பாருங்க? it is at a height d by 2 தானா? from the reference means mg into d by 2. Okay va? So this is about the initial kinetic energy, potential energy and final kinetic energy, potential energy. But இங்க என்ன தெரியுமா? when you look at the motion of the object along the inclined plane. இப்போ என்ன, we'll just look at the motion of the object along the inclined plane. இங்க பாருங்க, so the object is moving along the inclined plane. In the movement என்ன தெரியுமா? when you look at this movement, இப்படி தான வந்து it is coming like this. என்னென்ன force இருக்கும்? normal reaction இருக்கும். ஸோ கிராவிட்டி பற்றி நம்ம இங்கே பேசுறது கிடையாது, பிகாஸ் கிராவிட்டி இஸ் ஆல்ரெடி இன்க்ளூடட் இன் த பொட்டன்ஷியல் எனர்ஜி டேர்ம், அதில் வருது. ஸோ நார்மல் ரியாக்ஷன் இருக்கும், பட் த பாடி இஸ் மூவிங் அலாங் த பிளேன், ரைட்? ஸோ ஒர்க் டன் பை த நார்மல் ரியாக்ஷன் எவ்வளோ? 0. சின்ஸ் வென்எவர், ஸோ இங்கே மட்டும் கிடையாது, வென்எவர் த ஆப்ஜெக்ட் இஸ் மூவிங் அலாங் த இன்க்ளைன் பிளேன், work done by the normal reaction, it will be always 0. Okay va? Other than normal reaction, there will be friction. They are giving us coefficient of friction between the surfaces 0.1. Since there is a motion, we will consider the friction is what? Kinetic friction. Relative motion irukka, so adanaala we will consider the friction as what? Kinetic friction. When you look at the kinetic friction, right, kinetic friction oda value enna? Mu into normal reaction. Okay, so இப்போ நமக்கு என்ன வேணும்? நார்மல் ரியாக்ஷன் வேணும். ஓகே, மியூ தெரியும், மியூ 0.1. நார்மல் ரியாக்ஷன் எப்படி கால்குலேட் பண்றது? ஃபார் திஸ் ஆப்ஜெக்ட் விச் இஸ் ஆன் த இன்க்ளைன்ட் பிளேன், மோஷன் இஸ் ஓன்லி அலாங் த பிளேன், பர்பெண்டிகுலர் பிளேன் மோஷன் கிடையாது. இங்க பாருங்க, ஐ திங்க் யூ கைஸ் ரிமெம்பர் இட். இது என்னது? தீட்டா 30. mgயோட காம்போனன்ட்ஸ் mg cos theta will be perpendicular to the plane, mg sin theta will be along the plane. So when you do the force balance, right, idella nam already pannirukkom Newton's laws of motion la. Okay, so in the direction which is perpendicular to the plane, nama force balance panna enna varum? Normal reaction value is equal to what? mg into cos 30. Normal reaction value enna? mg into cos 30. Okay va? So this is what is the normal reaction value. So adilende namakku frictional force varum. So what is the frictional force? Mu into normal reaction, that is the frictional force. What is the frictional force value? Mu into normal reaction. Okay, so frictional force value na mu is what? 0.1 into m into g into cos 30. Okay, so idhil enna theriyuma, we will substitute the value of g எவ்வளவு? 10. 10 இங்க அப்படியே substitute பண்ணா 10 into 0.1 எவ்வளவு? 1 ஆயிடும். So which is what? Value wise it will be what? m into cos 30. அதுதான் frictional force value. இங்க பாருங்க, when the object is moving along the plane upwards, right, frictional force எப்படி ஆக்ட் ஆகும்? opposite direction தானா, which means angle between them 180. So work done by the frictional force என்ன பாருங்க, what is it? Frictional force value m into cos 30 into the displacement which is d into cos 180 varum. Idhanala cos 180? Because the displacement is upwards the plane, frictional force is what? Downwards the plane. Okay va? So that is why we will get what? Cos 180 varum, which means work done by friction will be negative. Inga parunga, cos 180 is what? -1 dana. So what is it? Cos 30 எவ்வளவு? √3/2. So minus md into √3/2. இதுதான், this is what is the work done by friction. இதனது this is what is the work done by the friction. Okay வா? So இப்போ என்ன வரும் பாருங்க, there is a work done by the non-conservative force. What is the work energy theorem statement? Work done by non-conservative force and other external forces is equal to what? Change in kinetic energy plus change in potential energy. Adana, what is the modified work energy theorem statement? Work done by non-conservative force and other external forces is equal to what? Change in kinetic energy plus change in potential energy. Ipo parunga, what is the work done by the non-conservative and other external forces? Verum in the friction mattum da irukka. What is this? Minus md into √3/2. That is equal to change in kinetic energy. Parunga, change in kinetic energy means what? Final level of 0. Initially this is, so 0 minus half m into 60 square. 60 square, so now what is it? 3600 plus change in potential energy, which is what? Final potential energy. Inga enna theriyuma, we will substitute the value of g as 10. Inga 10 substitute panna 2 1s are 2 5s are. So what is it? m into 5 into d minus 0. Initial potential energy 0. So this is the final equation. What is the equation? Work done by non-conservative forces and other external forces is equal to what? Change in kinetic energy plus change in potential energy. All of that. That is what is the work energy theorem modified statement. இங்க என்ன தெரியுமா, இங்க பாருங்க m cancel ஆயிடும், அங்க இங்க m cancel ஆயிடும். So what you will have minus d into root 3 by 2 is equal to இது என்னது 2 ones are 2 1800s minus 1800 plus 5d. ஓகேவா? ஸோ இப்போ நம்ம என்ன ரீஅரேஞ்ச் பண்ணலாம், ரீஅரேஞ்ச் பண்ண என்ன வரும், இந்த மைனஸ் 1800 லெஃப்ட் சைடில் எடுத்துகிட்டு வரலாம். ஸோ இட் வில் பிகம் வாட் ப்ளஸ் 1800 இஸ் ஈக்குவல் டு வாட், ரைட் சைடில் வில் ஹவ் வாட் 5d plus d into root 3 by 2. So 1800 is equal to what, d into 5 plus root 3 by 2. Okay, so இங்கே என்ன வரும் தெரியுமா 1800, இது என்ன, like we can simplify it. So root 3 is what 1.732 divide by 2 பண்ண என்ன வரும், this is what 0.866. So 5 plus 0.886 is what 5.886. So 1800 divided by 5.866, that is equal to what, d oda value. Check பண்ணி பாருங்க. So இது நம்ம simplify பண்ணலாம். If you want to get the value in terms of approximate means we can simplify it. இது என்னன்னா we have to look at the specific problem and do it. Okay. Sanju Vikashini, you are saying answer is 14. So is it for the previous question or in the question? 10 root 2. Okay, so for the previous question. In the question paranga 1800 divided by 5.866. Approximate சொல்லலாம். What is the answer? So இதுல என்ன தெரியுமா, this is the maximum complexity. ஏன்னா இதுக்கு மேல நமக்கு வராது. So neat level ல if you are having an inclined plane, object move பண்ணும்போது including friction, இங்க என்னன்னா we will have the அந்த modified work energy theorem full application. இவ்வளவுதான். This is the maximum complexity we will have in the neat level. Okay, so இதுக்கு மேல நமக்கு வராது. So இதுல என்னன்னா ஒரே ஒரு see, இதுக்கு முன்னாடி நம்ம பார்த்த ப்ராப்ளம்ஸ் இல்லைன்னா கன்சர்வேஷன் ஆஃப் மெக்கானிக்கல் எனர்ஜி, அங்கே அதுக்கு ஒரே டிஃபரன்ஸ் என்னது, இன் கேஸ் ஆஃப் தோஸ் ப்ராப்ளம்ஸ் அங்கே ஒர்க் டன் பை த நான் கன்சர்வேட்டிவ் ஃபோர்ஸ் ஆர் த அதர் எக்ஸ்டர்னல் ஃபோர்ஸ், அந்த டேர்ம் கிடையாது. ஸோ அதனால we are getting what, initial kinetic energy plus potential energy is equal to final kinetic energy plus potential energy. இங்கே வர ஒரே ஒரு டிஃபரன்ஸ் என்ன தெரியுமா, we are having work done by those non conservative force also, அவ்வளோதான். அந்த ஒரு பாயிண்ட் தான் டிஃபரன்ஸ். ஓகேவா? ஸோ திஸ் இஸ் த கைண்ட் ஆஃப் questions we can have in work energy theorem application in terms of kinematics related problems. Okay, so check பண்ணுங்க, what will be the answer. நீங்க simplified பார்க்கலாம், what is the approximate answer that will come. Okay, so இதோட we will try to wind up the session. Next session என்னன்னா we will start with the applications of the work energy theorem in spring related, and இது ரொம்ப important. So spring related problems, right? So we will see lot of different type of cases. So we can have an object tied to the spring, அப்படியே keep it vertical, அப்படி இல்லாம you can have the spring horizontal, அங்க கம்ப்ரஸ் பண்ண மாதிரி இல்ல எக்ஸ்பேண்ட் பண்ண மாதிரி, or you can have the spring kept on the inclined plane. ஒரு inclined plane எடுத்துட்டு அதுக்கு மேல அப்படியே along the inclined plane நம்ம spring arrange பண்ண மாதிரி. We can have different ways of arranging the spring. ஓகேவா? So we'll see applications of this work energy theorem including that spring potential energy. ஏன்னா whenever we are using the spring, right, அங்க என்ன வரும், spring potential energy வரும். ஓகேவா? So we'll see problems based on that. அதுக்கு அடுத்த ஸ்டேஜ்ல என்னன்னா we will go and look at the vertical circular motion. ஏன்னா ஆல்ரெடி உங்ககிட்ட சொல்லியிருக்கா, that is a very special case. So we will try to see how we will apply the work energy theorem in the case of that vertical energy or vertical circular motion. Okay va? So we'll look at the spring related applications in the next session. அது முடிஞ்சதுக்கு அப்புறம் we will go to the vertical circular motion. Okay va? We will see in the next class.